Guys, in this tutorial, I'm going to solve question number 9, paper 1-3, summer 19. By looking at this graph, you have to recognize the graph of sine, graph of cosine, and graph of tan. By looking at this curve, till now we don't know it's for sine or cosine, especially we have a transformation. If you read the first part, the function f is equal p sine squared 2x plus q. Let's start first to revise for the graph of sine x. Sine x from 0 to 2 pi will be like this. But from 0 to pi, only this part, if it is from 0 to pi. What about sine squared? The graph of sine, this is sine. If it is written squared, this means this part, which is negative part, will be up because now will be positive because power of 2. So this is the graph of sine squared. So show the range of sine and the range of sine squared. Now the range of sine squared from 0 to 1. Range of sine x from -1 to +1, but range of sine squared x between 0 and 1. From the graph now it's clear. What about if it is 2? Sine 2x. Sine 2x will be stretch, and this stretch scale factor half. Scale factor half. So you will get from 0 to pi a complete wave, and from pi to 2 pi another complete wave. This is same if we have sine squared 2x. I will show the curve now of sine x, then sine squared x, then sine 2x. This is the graph of sine x. From 0, 1, 0, -1, 0. It's a periodic function, continuous. To sketch only from 0 to pi. Now, look at this curve. It's a graph of sine squared x from 0 to 1. This is the range. 0, 1, 0, 1, 0, 1. This is the graph of sine squared. If it is sine squared 2x, 1, repeat, so will be 2. This is the graph of sine squared, and this is the range from 0 to 1. Let's now back to part 1. This is the graph of sine squared, but we have a range. This is the range from the minimum value to the maximum value. I will explain algebraically how to get the range after this part. This is the minimum and this is the maximum. There is stretching horizontally, vertically. Now, the function is p sine squared 2x plus q from 0 to pi. The maximum value of sine squared 2x now is 1, and the minimum is 0. So if this part is 0, so the answer will be q. If it is maximum, means sine squared 2x is 1. So the answer will be p plus q. Now it's clear. You can identify the range of this function in terms of p and q. This is part 1. In terms of p and q, state the range of the function f of x more than q and less than p plus q. Again, sine squared 2x, the maximum value is -0, and the maximum is 1. Part 2, state the number of solution. The number of solution, it depends on the intersection of the function and intersection of the right side. P and Q are constant, so will be a horizontal line. So by drawing the line which represents P and Q, and the curve. We already have the curve. You have to draw the straight line. Y is equal to P plus Q. It's a constant value. So will be this line up. How many solutions? This line touch the curve at 2 points. So how many solutions? 2 solutions. You can estimate your answer if I ask to get the values of the answer graphically. So he asked only about how many solutions, just only 2. F of x is equal to q. By drawing the horizontal line, y is equal to q. This line touch the curve or cut the curve at how many points? Just only from 0 to pi for the domain. The curve and the line cut at or touch at 3. So how many solutions will be 3 solutions? Part C, have P plus Q. Q, but add have. This is Q. Then add have P only. So will be in between. So the answer 1, 2, 3, 4. So we have a 4 solution. Part 3, when P is equal to 3 and the Q is equal to 2, P is equal to 3 sine squared 2x, 3 sine squared 2x plus Q given 2. This is the function f of x is equal to 4. How to solve this equation? Q is 2. How to solve this equation? Find sine subject, sine squared 2x is equal, move 2 to the other side, 4 minus 2 is 2, then divided by 3 will be 2 over 3. Then by taking square root for both sides, sine 2x is equal to positive or negative square root of 2 over 3. Then we have sine 2x, sine 2x is equal root 2 over 3, and sine 2x is equal to negative root 2 over 3. To get the basic angle of 2x, just use shift sine root 2 over 3. Shift sine root 2 over 3. You can write your answer 3 significant figure in red. You will get 0.955. By the same way, the basic angle is 0.955. Be careful when I say a basic angle, I will use only the positive value. Then we'll find all the cases. So back to the first one, sine 2x given positive. In which quadrant positive? Sine 2x positive in first quadrant and second. For the first quadrant, done, which is 0.955. But for the second quadrant, it's 180 minus or pi minus. So 2x, you will get pi minus this value, pi minus 0.955. You will get your answer is 2.1865. And also the third quadrant for the 2x is equal to negative. Sine 2x is negative. In which quadrant? Third and fourth. For the third, 180 plus 0.955. Fourth, 2 pi minus 0.955. This is 2x and this is 2x. For the first one, pi plus 0.955. So the answer is 4.0965. And 2 pi 2 pi minus 0.955. So the answer is 5.328. Look at the range of x. The range of x written up from 0 to pi. The range written from 0 to pi. But we have 2x. If you extend the range, so 2x between 0 and 2 pi. This is why I found all the cases. Now we'll try now all in the range. Yes, in the range. So try to find x for each. We have 4 solutions. The first one, 0.955 divided by 2. So the first is 0.4775. We can write 8. Second one, 2.1865 divided by 2. So the answer is 1.09. Third one, 4.096 divided by 2. So the answer is 2.048. 5.328 divided by 2. So the answer is 2.664. So we have 4 solutions.